Specify solutions of a system of equations. So that's our objective, is how do we do this? Okay, so a couple words that you have to know when you classify a system. One option is you can be inconsistent. Inconsistent. That means that the two equations have no points in common. And if you think about that from geometry, the only way that can happen is if you have parallel lines. So the slope is the same, but the y-intercept is different. Not sure what I just wrote there, but now I'm going to get it here. A different y-intercept. Okay. The next category that we can have is kind of two-part. Consistent. You can be consistent independent, and you can be consistent dependent. Consistent says you've got at least one solution. So something's happening, these two lines are crossing in at least one place. When you are consistent independent, you have only one point in common. Only one point in common. If you are consistent dependent, the two lines lie on top of each other, and every solution to the first equation is also a solution to the second equation. These lines actually lie on top of each other. So let's take a peek at what this looks like. Inconsistent, parallel lines, no solutions. Consistent, independent, one solution only, one solution only. Consistent dependent, you see how I have a green dotted line on top of the red one? You can't tell it on your notes. You might want to draw this with colored pencils, but this is infinite solutions. It's not that every solution, every ordered pair is a solution, but particularly what it says is that if you have a solution in the first equation, it is also a solution in the second equation. So these are the problems that we just did in the last video, and I have them all done here neatly. And now all that's left to do is to classify them. So I'm going to change my pen here real quick. Notice that I have one solution. So it is consistent because I have one. And there's only one, so it is independent. Do you see how I write my I like a 1? That helps me remember that that means there's only one solution. Okay. All right, this one we solved by graphing. Here are all the particulars. Once again, I have one solution right there, 3, 0. So this is again consistent because there is one, and independent. This one, remember this one we had the two lines lying on top of each other. So every solution to the first equation was also a solution to the second equation. Infinite solutions. So if you look back at that slide, I think it's 2, 3, I think it's slide 3. This is going to be classified as consistent because there are solutions, consistent, and this one is dependent. Dependent. It's like, think of them, they lie on top of each other like they're supporting one another. They are dependent on each other. Our final system that we graphed, these are two parallel lines. They never intersect. That means they never have any points in common. There are no solutions. And so we would classify this as inconsistent. So feel free, if you need to, re-watch this. It's very fast, and just to give you a stronger feel for what's going on. Okay? Thank you for watching.